about the introduction of stoichiometry, why we are studying this subject and how much it will be helpful in the upcoming subjects. So here, let's briefly discuss what will be the course learning objectives. So first objective will be to develop the material and energy balance calculation strategies for chemical processes. Since you have already studied non-reacting systems or physical systems in Stoichio 1, so here mainly we will be focusing on the reacting systems, although there will be some cases we'll discuss the recycle or bypass problems in physical systems or non-reacting systems and in reacting systems as well. But our main focus will be on the development of material and energy balance calculation strategies. And then second objective will be to formulate and solve simultaneously material and energy balance equations for complex chemical processes. Now, what does the complex term means? Complex chemical processes. It means that there will be multiple chemical reactions involved. There will be multiple units involved. Units means there will be multiple unit operations involved. So they can be physical, they can be chemical, but here we will be focusing on chemical processes and how we should apply material and energy balance simultaneously, which I told you earlier, it will be very much useful in your final year project as well. And when you will be studying thermodynamics one as well, there is also topics of material and energy balance. So these two subjects go side by side. Whatever you will learn here or in thermodynamics one, that will be related to stoichiometry as well. So this course is intended to develop a student's skills in problem solving, to help a student in applying material balance for processes involving chemical reactions and multiple units. Multiple units means there can be a reactor or distillation column or a mixer or some evaporator as well. So multiple units can be there in series or in parallel. Next, to help a student in applying energy balance for processes with and without reaction, and to give a solid background in chemical processing. Okay, now stoichiometry, stoicho means elements and metry means to measure. This is the mathematical part of chemistry, and it is actually the study of quantitative relationships between the amounts of reactants used and amounts of products formed by a chemical reaction. Now it is based on the law of conservation of mass, which states that mass cannot be created nor it can be destroyed, rather it can be converted from one form to another form. So we will be discussing steady state and unsteady state problems. Our focus will be on steady state, but obviously we will be looking for some unsteady state things as well. Since next week you will be, our classes will not be online. आप लोग आ जाएंगे campus में, then the reaction part or the in detail part we will be discussing in the lecture, in the classroom, inshallah. So there were some terms which we revised last time, and I asked you guys to revise units and dimensions especially. So I hope आप लोग करके आए होंगे कुछ ना कुछ revise. So here again हम इसको एक दफ़ा go through कर लेते हैं. Dimensions are basic some concepts of measurements like mass, length, temperature, etc. Again, next table में I will be showing you some dimensions and their units as well. Units are some means of expressing these dimensions, like length can be expressed in terms of meter or centimeter or feet, and then these can be fundamental and derived units. Fundamental are independently, they can be measured, while derived ones will be from using the fundamental quantities. Then there are moles. These can be gram moles or pound mole, and they can be calculated by dividing some given mass of a substance divided by its molar mass, molecular weight. So next one is density. Density is mass per unit volume of any substance. Then there is specific volume, which is actually inverse of density. Then there is flow rate. Flow rate आपके पास क्या है? This is actually the rate at which a material mass it is transported through some pipe per unit time, and it can be calculated in three different ways. Three different terms can be used. First one is mass flow rate. that is m, and for एक dots m dots से इसको indicate किया जाएगा. M dot, that is mass flow rate, it is equal to mass of a substance divided by unit time or whatever the time is given. Then there will be molar flow rate, moles of a substance to the time, and then there will be volumetric flow rate, ratio of the volume of a substance divided by ratio of a volume of a substance to its time. So next will be mole fraction and mole mass fraction and mole fraction. So whenever we are talking about more than two or more than two components, then there will be this will be a mixture or some compound. Then there will be terms of mass fraction and mole fraction, whatever the contribution of every component it has. So talking about the mass fraction, you are familiar with this mass fraction of any component. Like if you have a mixture of say three components, component A, B, and C, and you want to find the mass fraction of component A, then it will be equal to mass of component A divided by total mass of the mixture. Mass of A plus B plus C, total mass of the mixture. And if you want to find the mass fraction of B component, then it will be equal to mass of component B divided by mass of total mass of the components. This revision wait to नहीं कर रहा. Okay. So next is mole fraction. Same goes with the mole fraction. If you have some mixture and you want to find the mole fraction of a component, then it will be equal to moles of that particular component divided by total moles of the mixture. And if you want to convert it to the percentage, you have to multiply it by 100. So mass percentage and mole percentage can be easily calculated. Next, I have some problems or examples in further slides. I hope you guys have brought your calculators. You have it with you and your papers, and you have to solve some examples or problems, and then I will ask you after some time the answer, and you will share with me. And if you find some problem, I'll also share the solution with you. Okay, so next is limiting and excess reactant. Whenever we are talking about the reacting systems, there are some limiting reactant or some excess reactant. Limiting reactant, it controls the progress of the reaction. Its quantity is usually it is consumed first, and the excess reactant is left behind. And percentage excess, there will be some problems where we will be calculating the percentage excess of the excess reactant as well. So next is degree of completion and conversion. So conversion is the conversion means it is general for any reactant. Any reactant which is being converted to the products, we can find its conversion. It can be measured in percentage terms, and then degree of completion, it is actually for the limiting reactant. So how much a limiting reactant is converted to the product, that will indicate the degree of completion of the reaction. Obviously these terms, these are just the revision. Next we will be doing some problems, and you will calculate all these values. Hopefully they will be repeated in them. So next just a revision of dimensions and units. So this is the table 2.1 from your book, 8th edition Himmelblau, and the units encountered in this book: physical quantity, length. In SI में पहले ये बात होगी, length है, mass, time, temperature, amount of substance. These are basic units, and their SI units are written in the second column. Meter में है, mass will be in kilogram, time will be in second, temperature will be in Kelvin, and amount of substance in mole. And then next column में symbol for unit आएगा. You are familiar with this. Further, there are derived SI units, and they will be force or energy, power, density, velocity, acceleration, pressure, heat capacity, time. Alternate units are further other than SI units. हम इसके अंदर इनके अलावा further इनके units कुछ और भी use कर सकते हैं, वो भी आगे लिखे हुए हैं. Like time can be measured in time can be noted in minutes में भी हो सकता है, hours हो सकते हैं, days हो सकते हैं, year हो सकते हैं. ये सब conversions हैं. आप लोगों ने वैसे वो रिवाइज की भी हैं या नहीं? कोई देखे हैं अपने पिछले नोट्स निकालने हैं? class. बोले
यस मैम।
मैंने कहा आप लोगों ने वो ये यूनिट्स एंड डायमेंशंस वगैरह का पीछे से पढ़ा है? मैंने आपसे कहा था कि रिवाइज करके थोड़ा सा आइएगा चीज़ों को।
यस मैम किया।
देखिए चीज़ें थोड़ा बहुत ऑब्वियसली मैंने थोड़ा बहुत आप लोगों से एक्सपेक्ट कर रही थी कि आप लोग एटलीस्ट कुछ चीज़ें देख के आएंगे, ताकि जो चीज़ें मैं अगर नेक्स्ट आपको बताऊंगी तो वो बिल्कुल आपको एक डिफरेंट चीज़ नहीं लगेगी, क्योंकि नई बात मैं आपको बता रही हूँ, ठीक है? सो फॉर ऑल दिस इज जस्ट द रिवीजन। सो नेक्स्ट डायमेंशंस एंड यूनिट्स में अमेरिकन इंजीनियरिंग सिस्टम में हम देखेंगे फिजिकल क्वांटिटी, लेंथ, मास, टाइम, टेम्परेचर etc. Length will be measured in foot or inch, pound mass, second, hour, and then temperature will be in degree Rankine or degree Fahrenheit, amount of substance in pound mole, and further there are derived units. There will be a small example. If a plane travels at twice the speed of sound, which is assumed to be the speed of sound, that is 1100 feet per second. How fast is it going in miles per hour? You have to convert the speed of plane in miles per hour. So please calculate it. I'll ask you, or if anybody मुझे बता दे, otherwise I'll call some roll number and I'll ask इन साहिब या साहिबा ने किया है या नहीं किया। ओके मैं आपको
मैम वो स्क्रीन शेयर कर दे जरा प्लीज।
जी 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 इट्स हियर। A plane travels at twice the speed of sound. Assume that speed of sound is 1100 foot per second. How fast is it going in miles per hour? You just have to simply calculate the speed in miles per hour. किसी ने किया सोल्व?
यस मैम कर लिया।
Okay. Just wait please. Okay, what is your answer?
मैम आंसर है 3060 माइल्स पर।
मैम 300 है
जी
मैम 3600
1496
750
750 है।
ओके 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 चले मैं
25 माइल पर आवर
नहीं
750
नो इट्स 1500
1496
96 में कैसे चला गया?
मैम वो कन्वर्जन फैक्टर इन बच्चों का मतलब किसी ने 50 to 80 लिया हुआ
आपने जी आपने एक्चुअली कन्वर्जन फैक्टर वो थोड़ा सा चेंज हो जाता है। सो नेक्स्ट वीक में जब हम लोग इसको क्लास में करेंगे तो फिर मैं वहाँ पे ऑब्वियसली हर एक का इन पर्सन चेक कर सकूंगी कि आपने कौन सा कन्वर्जन लगाया। फॉर द टाइम बीइंग जो बिल्कुल सिंपल था ये मैंने आपको शो किया है। Since it is the sound of speed of sound is 1100 feet per second, and the plane travels at twice the speed, so you have to multiply it by 2. Okay, then next fit को miles में convert करना है, 1 mile 5280 foot, and then minute और second की conversion आ जाएगी इसमें. ठीक है, तो अगर आप दरमियान में दूसरी calculation के through भी चलते हैं, then even then आप you reach the same answer. तो वो अभी तो obviously I cannot check your notebook आपने किस तरह से solve किया है, but you can compare your method with mine. और फिर नेक्स्ट वीक में जो है वो इट्स बेटर कि हम सामने बैठ के आप लोग मेरे काम करेंगे, तो आई विल चेक इट. ठीक है, आगे चलूं?
Yes, ma'am.
Okay. Yes, ma'am. Okay. So next one. This is also very simple. This is about the mass fraction and mole fraction. So this is also an example from your book. An industrial strength drain cleaner. It contains 5 kilogram of water and 5 kilogram of sodium hydroxide. What are the mass fractions and mole fractions of each component in drain cleaner container? Container के अंदर जो water है और sodium hydroxide है, you are given masses of both the components. You have to find the mass fractions and mole fractions of each component. Okay. So I think you know how to take the basis of some problem. First of all, you have to select the basis. So here you are given the masses of individual components. You can add these components and you can take in an overall basis. So 5 kilogram of water plus 5 kilogram of sodium hydroxide, total आपके पास जो mass है, that will be 10 kilogram. So आपकी basis जो होगी, that will be 10 kilogram of solution जो भी आप इसमें है. So next आप please इसको solve करें. देन आफ्टर 2 मिनट्स में आप लोगों के साथ इसका सोल्यूशन जो है वो शेयर करूंगी, आप ही कंपेयर कर सकते हैं इसके साथ.
Ma'am,
जी.
the both fraction of both of them would be 0.5.
Weight fraction, yes, mass fraction is same for both components.
Yeah, but now I'll calculate the more.
Yeah, please go ahead.
Ma'am, mole fraction of water is 0.5, 0.02, and molar fraction of NaOH is 0.0125.
No, I'm sorry, but it's not correct.
Mole fraction of water is 0.68 and the mole fraction of NaOH is 0.32.
Yes, this is correct. Here is the solution as well. Please आप अपना इसके साथ compare कर लीजिएगा. Have you finished?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, class. One thing I will add here, if you want to calculate or if you want to make the calculations or solve the problem in table form, like I have done here, it's fine. If you want to do it in this, like making sections and then perform it in this sequence in bridge method, I'm fine with that. So anything which is okay for you, which is convenient for you, that will be most welcome as long as your strategy is correct. आप कोई भी मेथड यूज कर सकते हैं इसको सॉल्व करने के लिए इन फ्यूचर एज वेल. आप फ्यूचर में कोई भी मेथड आप यूज करें बट दैट शुड बी करेक्ट. Strategy should be correct. Obviously, there are multiple routes to solve any problem. You can adopt any one, and if it is correct, I'll give you complete. I mean, that will be fine. I'm fine with any strategy. Okay, so here total mass is 10 kilogram. You have to take the basis of 10 kilogram of solution. So in the table components column, that is water and sodium hydroxide, then next is weight, which is given in kilograms, 5 kilogram and 5 kilogram total is 10. To find the weight fraction, weight of a single component divided by total weight, which is 0.5. Then weight of second component divided by total weight, which is also 0.5. And sum of both fractions is 1. Then molar mass of each component, water 18 kilogram per kilogram mole hai, and sodium hydroxide is 40 kilogram per kilogram mole. And to find the kilogram moles of each component, you have to divide the weight of component divided by molar mass. So 5 divided by 18 will be 0.278 and 5 divided by 40 will be 0.125. So adding these two quantities, it will be 0.403 kilogram moles. Further, you have to find the mole fraction. So divide moles of individual component 0.278 by 0.403 total moles. It will be 0.69, and then 0.125 divided by 0.403 for sodium hydroxide, it will be 0.31. This will be the mole fraction, that is the sum of, and sum of both fractions will be 1. Now in the question, if you are asked about the percentage, to tell me the mole percentage, you simply have to multiply, another column will be added here, and that will be mole percentage. और यहाँ पर आप 0.69 multiply by 100, that will be 69%, and then 0.31 multiply by 100, it will be 31%, and sum of both percentages, it will be 100. Okay, so you have to according to the question, you have to formulate your own tables. You have to see if you are asked in mole fraction, you simply mole fractions, mole percentage is simply multiplied by 100 and you will get the answer. Okay, so आगे move करें.
Yes, ma'am.
So next is to calculate the average molecular weight of air, assuming that air is 21% oxygen and 79% nitrogen. Although air contains argon as well, but since that is also inert component and nitrogen is inert, so as a whole total हम यही कहते हैं 79% nitrogen इसके अंदर present है, ठीक है? So average molecular weight, I think you know how to calculate it. You have to take some bases. Firstly, since it is a mixture of gases, so bases will be in moles. Either in gram moles आप ले सकते हैं या pound mole भी आप ले सकते हैं. Both will work. So 1 gram mole of air आप basis लेंगे, and then there will be moles of oxygen. वो आप calculate करेंगे, moles of nitrogen निकालेंगे, ठीक है, and then आप इनकी masses में इनको convert करेंगे. As you know, average molecular weight, इसका formula क्या होता है? This is equal to mass of the mixture divided by total moles of the mixture. ठीक है, आप 1 मोल की बेसिस भी ले सकते हैं, आप 100 मोल्स की बेसिस भी ले सकते हैं. It's your choice. ऑक्सीजन का मोलर मास जो 32 है और नाइट्रोजन का 28 है. Okay, so class, I have shared both the solutions, one done by one which is solved in your book, and second is the one I solved by using by solving all the calculations in table form. So you have to take 1 gram mole of air. Then first you have to calculate the masses of both the components. So mass of oxygen will be in 1 gram mole. Oxygen उसमें कितना होगा 0.21 gram mole. And then आप इसकी mass calculate करेंगे 6.72 grams. Second one is mass of nitrogen in 1 gram mole air. Since it is 79%, so it will be 1 into 0.79. That is 0.79 gram mole. इसको molar mass से multiply करेंगे तो आपके पास total mass आ जाएगा. So and to find the average molecular weight, आपने total mass should be divided by total moles. So this is total mass divided by total moles. आपके पास average molecular weight आ जाएगा. That will be 29. Same मैंने जो solve किया है here, I have solved it by using a different basis. Like I took here 100 pound moles of air. So component is oxygen and nitrogen. Since mole percentage is which is given in the question for both the components, oxygen is 21% and nitrogen is 79%. Then molar mass is also given. Since I'm here solving American engineering, so molar mass will be in different units, pounds per pound mole. Oxygen is 32 pounds per pound mole, nitrogen is 28 pounds per pound mole. Then weight हम दोनों का calculate करेंगे. For oxygen, total number of moles कितने आएंगे. यहाँ पर एक column भी आप कर सकते हैं. Mole percentage and mole यहाँ पर equal ही है 100 क्योंकि 21 moles multiplied by 32, 672 weight है, and nitrogen 79 into 28 2212 इसका total weight है. So आप इस दोनों को add करेंगे 28.84. फर्दर वेट परसेंटेज भी हम यहाँ पर इनकी निकाल सकते हैं. इफ़ यू आर आस्क्ड, अगर आपसे पूछा जाए आप इसमें वेट परसेंटेज निकाल सकते हैं. यहाँ पर मैंने ये जस्ट इसलिए शो किया जस्ट टू गिव यू एन आइडिया कि हाउ क्वेश्चंस कैन बी मॉडिफाइड एंड इफ़ यू आर आस्क्ड एनीथिंग. इफ़ यू आर नॉट आस्क्ड वेट परसेंटेज, जस्ट skip this part. And then to find the average molecular weight, total weight of the mixture divided by total moles of the mixture. So here weight is 2884 divided by 100 pound moles. So यहाँ पर ये आया राउंड ऑफ करके ये 29 है. यहाँ पर मेरा और जो आपके बुक से क्वेश्चन में थोड़ा सा डिफरेंस आया. डिफरेंस क्यों आया यहाँ पे? बिकॉज मैंने यहाँ पर जो मॉलिक्यूलर वेट है वो थोड़ा सा डिफरेंट लिया हुआ है. ठीक है, वहाँ पर उन्होंने 28.2 के साथ किया, मैंने 28 के साथ किया है. तो आपको जो भी क्वेश्चन के अंदर वट एवर मोलर मैस विल बी गिवन, यू हैव टू फॉलो दैट मोलर मैस. एंड आप 32 या 28.2 लेते हैं, इट डजेंट मैटर, आप कोई भी वैल्यू इसमें ले सकते हैं. ओके, आगे चले. इज इट क्लियर?
Yes, ma'am.
ओके,
मैम काइंडली पीछे कीजिएगा दूसरा मेथड एक.
जी,
थैंक यू मैम.
ओके. ओके, आगे चल रहे हैं. So next one, again mole percentage, mole fraction से related है. Okay, a gas mixture, it contains 40 pound of oxygen, 25 pound of sulfur dioxide and 30 pounds of sulfur trioxide. What is the composition of the mixture? You are going to calculate. It will be percentage or mole percentage.
percent.
Why mole percentage? When you are dealing with gas, mole percentage. Case of solids, mostly weight percentages are given. Both can be the cases. So here it is not mentioned whether you have to find the mole percentage to find the mole percentage of each component. So gas mixture, it contains 3 components. आपके पास तीनों की masses given है. You have to find the composition. Please solve it. Then I'll share the solution as well. I hope all students are solving it. This is for your own benefit. आपका फ़ायदा है इसमें. साथ साथ प्लीज़ आप सब लोग इसको सॉल्व करें. I know ये बिल्कुल बेसिक चीज़ें हैं. You have already done all these problems in Stoichiometry-I, but just एक रिवीजन है so that जब हम आगे मूव करेंगे complex problems की तरफ थोड़े वहाँ पर फिर आपको difficulty नहीं होगी. So what is the percentage of oxygen? Anyone?
62%.
Yes, it's here. आप देख सकते हैं. Please compare करें अपने answers को. All 3 components. Sorry, it is oxygen के साथ था या? Sorry, यहाँ पे here it is not carbon dioxide, it is oxygen. ठीक है, this is a mistake. It's actually oxygen. So here weight of individual components is given. आप इसी की basis ले सकते हैं total करके. यहाँ पर I didn't write it, but you have to write in the start. Basis आपकी होगी 40 plus 30, 70, 95 pound of the mixture. And then weight, individual weight is given. Molar mass, you know them in pounds per pound moles. Then you have to find the moles of individual components. Total moles are find out करेंगे 2.016, and then you find the mole fraction of each component, and sum should be equal to 1. Okay, clear है class?
जी मैम.
Yes, ma'am.
Okay, I assume जो लोग खामोश हैं एटलीस्ट वो लोग सॉल्व कर रहे हैं और उनको समझ भी आ रही है साथ साथ. ओके, अब आगे देखते हैं इसका. आगे अगले प्रॉब्लम पे चलें.
Yes, ma'am.
मैम जस्ट 1 मिनट दे रहे हैं.
जी 1 minute टेक. take your time. Okay, I'm moving to the next slide. Previously, I think किनका माइक ऑन है जी है 23 एक्सक्यूज
मैम आप इनको खुद भी म्यूट कर सकते हैं।
सॉरी जी बेटे ओके Okay, so next example देखें. A natural gas has the following composition by volume. Methane is 83.5%, ethane is 12.5%, and nitrogen is 4%. We should calculate composition in mole percentage, composition in weight percentage, and part C is average molar mass, average molecular weight. You are given percentages by volume. First, you should take some bases in ग्राम मोल्स ले सकते हैं किलोग्राम मोल्स ले सकते हैं पाउंड मोल्स ले सकते हैं वट एवर यू लाइक इट कैन बी 1 ग्राम मोल और 100 ग्राम मोल एनीथिंग Anybody done with part A? Have you calculated composition in mole percentage?
मैम मोल परसेंटेज तो सेम ही होगी ना वॉल्यूम वाली
जी जी बिल्कुल you are right. In case of gases, volume percentage is equal to mole percentage. So same percentage will be for the composition will be same in mole percentage as well. So actually you have to calculate for part B, composition in weight percent.
Ma'am, weight percentage of methane is equals to 73.3%.
Yes.
C2H6
Okay, that's
is equals
okay.
to
If your one percentage is correct, that means the rest are also correct. Ethane must be 20.6.
ma'am 20.05.
That's okay. And then nitrogen. This is the solution. Okay, I'll share the solution later. Average molar mass रह गया. Did you find out?
18.2.
Yes. Okay, so this is the solution. I did the calculation in pound moles. आप इसको मैंने बताया ग्राम मोल्स में ले सकते हैं, किलोग्राम मोल्स कुछ भी ले सकते हैं आप, ठीक है? There should be no confusion in it. पहले आप लोग ये कंप्लीट कर लें, देन हम इसको डिस्कस करेंगे फिर. Okay, so class, firstly, you have to take basis of some moles, 100 moles of gram moles, kilogram moles, or pound moles of the gas mixture. Part A was to calculate the composition in mole percentage. So for the case of gases, volume percentage is equal to mole percentage, so composition will be same. In the second part, you have to find the weight percentage. So in the table, components, three components are given. Firstly, individual components, you will find out that is methane is 83.5, 12.5, and nitrogen is 4 pound mole. Sum is equal to 100. Then molar masses of individual components, methane ki 16, ethane, and nitrogen. Since I am using pound moles here, so I have written the molar masses in pounds per pound moles. Next, you have to find the weight of individual component. Just multiply the pound moles of every component by its molar mass and you will get the weight of individual components. Then the sum of all these components is 1827 pounds. Further, you have to find the weight percentage of every component, weight of individual component divided by total weight, that is 73.3, and then same for ethane and nitrogen, and sum of all the percentages is 100. Part C was to calculate the average molar mass, that is equal to total weight of the mixture divided by total number of moles. So total weight अभी हमने calculate किया, that is 1827, and total moles we have taken the basis of 100, that will be 100 and 18.27 pounds per pound mole इसमें आएगा. If you have taken the basis of 1 pound mole, simply यहाँ पर फिर आपके पास जो mass होगा that would be 18.27. Okay, थोड़ा सा difference आएगा. आप लोग इसमें you can cross check it. The students who has taken the basis of 1 pound mole or 1 gram mole, you will take the weight in grams will be 18.27 grams. Okay, और जो आपके पास total weight 18.27 divided by 1 होगा, that will be answer आपका same आएगा. So you can take any basis. You can take even 50 pound moles of gas or whatever basis you want to take, but 100 is easy to understand and easy to remember, easy to deal with. So 100 or 1 pound mole, 1 gram mole, whatever basis you want to take, just take it, and your strategy should be correct, your method should be correct, or then your answer will be will also according to the according to my answer. Okay. So this was all about the non-reacting systems. If you have any question, just ask me so that we will move further. Okay. Okay, class. This was all just for your practice. Maybe some of you remember thinking this is just the basic things, but actually this is what your what the start is, and step by step we will move further. Yes, ये अभी कौन सा शरीफ ला रहे हैं? Page 6. Okay. Next, I think आज के लिए इतना ही होगा. Next time we will move the chemical reaction side, or if I find some other things which are related to the non-reacting systems, like just the revision cases, that will be discussed further in next class, inshallah. Until then, I will request all of you to please remember or revise all your units and dimensions, and then we will because with the passage of time, repeatedly you have to face them. आपके पास pounds आ रहे हैं, pound mole मैंने अभी बताया. मैं भी जिस तरह से चीज़ें कभी पाउंड मोल्स में लेके जा रही हूँ, कभी ग्राम मोल्स में लेके जा रही हूँ, सेम आपके साथ भी हो सकता है. ठीक है, तो आपको इसकी बेसिक अंडरस्टैंडिंग होनी चाहिए. ये यूनिट्स एंड डायमेंशंस, स्पेशली यूनिट्स कन्वर्जन आपको याद होने चाहिए, आपकी टिप्स पर होने चाहिए ये चीज़ें. सेकेंडली, देयर इज अनदर थिंग which I would like you to perform by yourself. That is to find out the density of this gas mixture. The same example which is displayed on your screen. Here A, B, C, and then part D is to calculate the density of this mixture. Next time I will ask you its answer, and because it's on average molecular weight, and then question is density at standard conditions. Okay, density at standard conditions पे आपने find out करना है, and for that you have to find first calculate the value of universal gas constant, that is R. Okay, so actually part D is your understanding of calculation of universal gas constant. So I would next time मैंने इसीलिए कहा ताकि मैं देख सकूंगी कि आप लोगों ने वो calculation of R को understand करते हैं आप या नहीं करते हैं. ठीक है, just इतना सा काम है. You have to check the density of this gas mixture and to understand the calculation of R, how you can calculate the value of R at standard conditions in SI system and in American engineering system. Okay, do you get my point?
Yes.
Yes,
Yes, ma'am.
Very simple thing. Okay, so any question, or हम फिर इंशाल्लाह ताला नेक्स्ट में अगला टॉपिक जो है प्रॉपर्ली, दैट इज mass relations in chemical reactions, इसके ऊपर फिर हम प्रॉपर्ली मूव करेंगे, बिकॉज नेक्स्ट प्रॉब्लम्स आर टू फाइंड आउट द लिमिटिंग रिएक्टेंट, एक्सेस रिएक्टेंट, देन रिएक्टेंट्स एंड प्रोडक्ट्स. सो वो हम एक शिफ्ट में करना चाहेंगे. ठीक है, नेक्स्ट लेक्चर के अंदर. ओके क्लास.
मैम इस स्लाइड्स आप टीम को सेंड करेंगे लेक्चर आज?
आपने उसके साथ साथ सॉल्व किया भी है, इफ यू वांटेड तो मैं आपके साथ शेयर कर देती हूँ, अदरवाइज चीज़ें तो वही हैं. अगर एक और चीज़ अगर आप ऐसे मुझे बता दें, अगर आप बुक वाला सोल्यूशन चाह रहे हैं, बिकॉज दिस इज लाइक ये मेरा अपना सॉल्व किया हुआ है. ठीक है, मैंने अपने जो किया. अगर आप बुक वाला ये इसमें चाह रहे हैं ज़रा वो क्या कहते हैं प्रेजेंटेबल बनाने के लिए, तो मैं वही वाले अंदर पेस्ट कर दूंगी लाइक दिस वन. तो अगर आपके लिए जैसे कन्वीनियंट होगा, मुझे लगा कि आपके लिए ज़्यादा कन्वीनियंट हो जाएगा इस तरह से जो मैंने खुद किया हुआ है, ताकि आपके लिए शायद अंडरस्टैंडिंग ज़्यादा बेटर हो जाए इसमें, जैसे आप लोग चाहते हैं.
कन्वीनियंट ही है ये.
हाँ चलिए ठीक है. बाकी तो अगले वीक से वैसे ही क्लासेस जो हैं इंशाल्लाह आप लोग कैंपस में आ रहे हैं, तो फिर वहाँ पर तो आप सामने जो भी प्रॉब्लम होगा आप क्लास में मेरे से सामने डिस्कस कर सकते हैं. उसमें तो स्लाइड्स का इन चीज़ों की फिर हमें इतनी ज़्यादा ज़रूरत नहीं रहेगी. ठीक है, चलिए. ओके क्लास, अगली क्लास में अगले लेक्चर में इंशाल्लाह आपसे मुलाकात होती है. अंटिल देन अल्लाह हाफिज़, अपना ख्याल रखिएगा.
अल्लाह हाफिज़ मैम.
अल्लाह हाफिज़ मैम.
अल्लाह हाफिज़.
Allah Hafiz, ma'am.